and running. Okay. So this tutorial is going to be about dealing with the Titanic machine learning competition here on Kaggle, and using most of the people that I know did this using Azure Machine Learning Studio, you know, just drag and drop in nodes and stuff like that. I mean, it's pretty straightforward and simple if you're going to choose that, but I'm gonna go with the I don't know, let's say a more advanced way of doing this by using Python and machine learning, I suppose. So this is the kind of script that not a script, let's say, I mean, this is a Python notebook. You can see it from the extension here, and it's running on, yeah, it's running here as well, a Jupyter notebook. Yeah, let me just go through this code actually. Yeah. So the first thing is that you need to get a machine learning environment up and running, and to do that you could use Anaconda or something like that. The documentation is already there. It's pretty easy. You download it and then you install it, and you activate an environment and install these packages. Yeah. So the first part. Now if you can see here, if I click on this part, you see a running icon here and a run icon here, which means that these are delimited like this. So this is one part, and you can run them individually if you want. That's how the Python notebook kind of works. So I won't go into detail about that, but let me just go and give you an introduction into what the dataset is. So okay, so when you go to the data over here, you can see that the data dictionary is over here. Now you have a test and a trained data set. Now the data dictionary defines what kind of columns and the kind of data that you're going to expect in there. So you see the passenger ID, and you see survived, if it's survived or not, the passenger class, the name, the gender, the age, and siblings and spouse report. That's a number, and the parent and child. There's a relationship between these things. I'll get on to that things later on in the tutorial. And ticket ID, fare, cabin, where they embarked. So the key to these things is that it's like for here it's 0 and 1, here 1, 2 and 3, it's 0 and 1 again for the gender, and 1, 2 and 3 again for the embarked things. You have to kind of go through the data and see if they already have this kind of a numeric key assigned to it. Otherwise, if it's just no or yes, you'll have to manually, manipulate the data and then swap these values with the relevant kind of a relevant numeric value of it. So just by the look of it, what it says is that we get a training data set and these kind of fields and attributes of it, and the objective of the machine learning the tutorial is to successfully predict if the test data set, if the passengers in the test data set survived or not. So this is the thing that we are going to predict, and this is the field that we're going to train our data set against. Okay, so I think the training set has 892 rows. The test set, yeah, I don't actually remember how much that is, but it doesn't really matter. So the methodology, okay, so the basic methodology is that in any machine learning tutorial or activity, there's a kind of standard methodology to follow. You should understand the question or the problem definition. What are they asking you, what kind of thing that we have to predict. You acquire the training and testing data, you wrangle, prepare and cleanse. Like I said, I mean, if there are null values, you have to kind of come up with a suitable way to fill them up or filter them out. You analyze and identify patterns between the fields and the data. There should be a relationship. There are relationships usually. And what you do next is that you model and then you predict and solve the problem. And in doing so, you can visualize and report and present the solution. And number 7, if you're doing a competition, you submit the results. So like here, the problem definition is knowing from a training set of samples listing passengers who survived or did not survive in the Titanic disaster. Can now model the model that we are going to develop, determine based on a given test data set not containing the survival information whether they survived or not, if those passengers in the test data set survived or not. So what we have to basically do is guess whether they died or not. Okay, to start, the first thing we are doing is importing certain libraries here. And pandas here is a data manipulation library. You can see here that I'm importing pandas as PD, and then I'm using PD to read the CSV file that contains the training and test data. I'm using warnings just to filter a type of warning called future warning, since I'm using Python 3.7, and I'm using matplotlib again, matplotlib to to create some plots, and again SNS Seaborn again for plotting. sklearn, I'm using the sklearn. Now this is a branch of the sklearn scikit-learn library. It's basically a machine learning. It contains a lot of machine learning algorithms in it that you can simply plug and play with. Okay, so the first thing is I'm loading the CSV file as a pandas dataset into this variable here. It contains the training data and then the test data. That's what I'm doing here. You can see it right here, and then I'm running the test df.shape. Now what shape does is gives you a kind of idea about how many columns, how many rows, and how many columns the in this case the test dataset has. So moving on, I'm printing whether how many nulls are there in the trained dataset, and then I'm adding kind of a divider here, and then I'm printing how many nulls are there in the test dataset. The first one is the trained dataset, the second one is the test dataset. So here you can go and see that there are nulls in age, there are nulls in the cabin that they stayed at, there are nulls in which city that they embarked. Now the first thing is in the training dataset. Now the second one is in the test dataset, and you can see it's again the same. You got 86 nulls, you got 327 nulls here in the cabin, but you got 0 nulls in embarked. So moving forward, you have to handle these nulls, because you can't simply plug these things into a machine learning algorithm and expect it to work. Now what I'm doing is that I'm using Seaborn again to draw a box plot of the survived passengers and their fare using the training dataset, and you can see it here. So it survived 0 and 1. 0 means that they didn't survive, and 1 means that they did survive. And their fare, you can see that it's basically a bit spread upwards, which means most of the people who survived had paid a higher amount than the people who didn't. That's what you can see from here. Okay, so I guess this is the box plot, and then again come in here. So like I said, the sex, the gender was either male or female. Now we can't use those words when using machine learning. So what I have done here is that I'm applying a lambda function over here. So what it says is that it passes the x value again based on sex. It'll return a value x0 if x equals female, else 1. Which means that in the training dataset, a 0 value means it's a female. And again in the test data set it's the same thing. We do the same thing and then we get the head. So you can see here this X has been replaced with 1 and 0s. This is part of cleaning the data set, so to speak. And again in the fair we had a little bit of nulls in the fair column as well in the test data set. So what we are doing is we are filling the null columns. Fill NA means fill the nulls. And what we are doing is we are using the mean of the fair in the test data set, and we are going to fill it in the same variable, the test df. And now again we're printing the head of the train df. This doesn't really matter, but that's what it is. So the next thing what we are doing is we are extracting the title. So if you remember the first remember the data dictionary over here, it didn't have a title, it had name. But when you explore the data you'll see that some of these will contain Mr., Miss and Captain, titles like that. So we are taking that out, we're extracting it by using this regular expression. So which means that it'll start with the capital A to capital Z, or maybe simple A to simple C, and then the rest will follow. And we're extracting it from the name tag. Yeah. And if we go to datadf.head, so here, let me see, the title is over here. You can see Mr. and Mrs. over here. Now in the next thing what we're doing is we are mapping all the titles that we collected, into Miss or Mr. or Mrs. That's what we're doing. Here's what we're doing. So replacing the title with the mapping, and again in the same thing. So now once we've done the mapping of the title, we are replacing the training dataset with the data df, starting from 0 to 891. Then the test df starting from 891 to the end of it. Again there's another title here. Now this title is used to calculate the age. Now if you remember, the age had nulls when we first explored the data. So what we're doing here is we are grouping each and every individual here, each and every row here, and we are grouping them by title, and then we are getting the median of the age we're getting the median of the age, and then we're getting the location where the age is null, and the age and the title is title. So let's say if the title is Mr. and their age is null, and you get a location, you are plugging in the calculated median to this row or rows. It can differ. So again we do the same thing. The training dataset is from 0 to 891. The test dataset is from 891 to the end, and that's what we're doing. And then we just see if how many nulls are there. Train dataset is null, and you can see that it's gone. Right, the age had nulls earlier, but now it's gone. Instead, there's a few in the cabin. Since the cabin isn't really important, what we're doing is we're dropping it. We drop in the cabin field, and now we go and see how many nulls are there. It's there in the embarked. So since it's just 2 nulls out of 892, we're just filling the embarked with S, as in that they got off at a certain point, at a certain port. Now again, this S is a string, and we can't use those strings in machine learning. and therefore what we're doing is that we are again using the map here. So S would map to 1, and C would map to 2, and Q would map to 3. And again we are replacing the embarked column with the embarked values in both the training and test data. And now we take ahead and we can see that the embarked is numbers. Okay, the other thing comes with PLT, or the subplot. So we are drawing a plot with a figure size of 18, 15 and 8, which means it's 15 wide and 8 high, and it's going to be a heat map, and it's going to map the correlation in the correlations of the training data set. You annotate it, and the color mapping is PIYG. So basically means this. You could use something else and this would look a little bit different again, but it would still have the heat map over here. So again, if you see the correlations here, okay, rather I'll show it to you over here. Okay, so the correlations are here. The greener the better, so which means if the box over here is greener rather than red, which means there is a certain correlation among those features, right? So for example, the number of siblings and the parents is 0.41, which means there's a relationship between these two parameters. And there seem to be again age and the gender, the sex, about 0.3, which means that we can get a certain idea that these features are related. This is really helpful in kind of visualizing the data and getting a certain idea about how each and every feature affects the final outcome. Anyways, this is the heat map, and this is survived versus non-survived in a gender distribution. So you can, this is just the labels male and female, so you can, if you go here again, I'll use this, it's much clearer. Survived and non-survived passengers. So you can see that the percentage of passengers that survived are mostly female, and it's about 0.73. So that's about 73% were female, and about 0.2, about 0.19. So that's about 19% were male, and that kind of gives you an idea about the about that distribution as well. And in the next one, it's the passenger class, which class they went, first class, second class, or third class, versus the survived and non-survived, right? So there were 3 classes, 1, 2, and 3. And blue means they didn't survive. The orange means that they did survive. So in the first class, you can see that about 75 have not survived, and about 140 had survived. And the biggest thing is that most of the third class did not survive. A little bit actually did survive, but we have to take into consideration the total number of people in each and every class. And this kind of shows that the majority of the passengers in the third class did not survive, regardless of their gender. So this is the fare distribution. You know how much that they paid. You can see that some had paid like $500 for it, and they did survive. Again over here, some of them. This doesn't actually show a lot of this doesn't show a big difference in the fare distribution actually. It's just that the frequency of passengers that who did not survive and who did survive, they all fall in the same kind of region. So this might be the ticket price. Yeah, again we are dropping name and ticket because these things doesn't affect the final outcome whether they survived or not. What we're doing is just splitting the X and Y. So we are training a model using X against Y. So y variable has the survived data, so it will contain ones and zeros, and the corresponding rows of it will contain the relevant fields that are necessary to train the model. So what I'm doing next is importing certain kind of classifiers, and then even regression machine learning algorithms. And you can see that I've used random forest, decision tree, logistic regression, and Gaussian and B, perceptron, and SGD classifier. So each and everything I'm initializing the variable, and then I'm fitting the X and Y here, and I'm gonna predict, and I'm going to score them, and I'm gonna score that value and then round it off to the nearest 100, so which means I could get a percentage of the accuracy. So the random forest classifier, it's an ensemble algorithm, which means that it has a multiple machine learning algorithms in it. So it gives an accuracy of 98.2. Again, decision tree classifier, it also gives an accuracy of 98.2. The regression gives you 80.58, which is a bit low, and Gaussian and B gives 79.57. That's out of 100, that's percent, so 68.13%, and SGD classifier would give 62.96. Now to see this much clearly, I'm using again a matplotlib pie plot, a plot here with a figure size of 12 and 8. So I'm using X. So the model will be on the X-axis and the score will be on the Y-axis, and yeah, so you can see here it's the same thing over here but together. So logistic regression would give about 80, and random forest would, if you can remember, gave 98.2. Naive Bayes, that's Gaussian and B, and perceptron, and then the decision tree, both of these are higher. The next thing that we do is get the submission. Like, you have to submit a certain CSV to Titanic, like over here. You have to submit that, and that contains the passenger ID and if they survived or not. So it's passenger ID and the predictions. And if you take the first 5 rows, it says that it gives the passenger ID and if they survived or not. So that's it. And we can save this to the disk and then upload this to here. And if you go to submissions, we have multiple submissions here, and each and every one of those was submitted, and you can see there's 0.81339. That's the accuracy. That's the accuracy score given by Kaggle. And right now we are at, let me see, we are at 508. 508 out of how many submissions? It's not here. Out of 11,039, we have 508 out of 11,039. So yeah, this is it. Thank you for listening.